वेलकम टू बी लर्न में आपका स्वागत है। सब्जेक्ट इन टूडेज सेशन बिजनेस स्टैटिस्टिक्स सेशन नंबर 6 and session number 6 is totally prepared by the distributions of probability or probability distributions like normal distribution, binomial distribution and Poisson distribution. Topics to be covered in this session: what the normal, binomial and Poisson distribution look like, what parameters describe their shapes, and how these distribution can be useful. So the normal distribution, also called Gaussian distribution or a bell-shaped curve, centered around the mean mu with a bias determined with the standard deviation alpha, total area under the curve equal to 1. So fx equal to 1 upon alpha square 2 pi minus exponential of x minus mu upon 2 alpha square, and the curve is drawn at this symmetry like for a mean of 5 and a standard deviation of 1. Mu equal to 5% set mean, sigma equal to 1% set standard deviation, x equal to 0.110% define x-axis, y equal to normal functions of x, mu, sigma, plot x and y. Like this curve, the portions, this portion is known as skewed portion and this is also known as other skewed portion. This is a positive portions and this is negative portion. And here it is the mean value which is equal to 5 and C is mu in the terms of standard normal distribution, and sigma here 5 to 1 minus sigma and 5 to more plus sigma. These are the values of standard deviation. So what does a normal distribution describe? ये हमें क्या बताता है? Imagine that you go the lab and very carefully measure about 5 ml of liquid and weight it. Imagine repeating this process many times. You will not get the same answer every time. But if you make a lot of measurement, a histogram of your measurement will approach the appearance of a normal distribution. Imagine that you hold a ping pong ball over a target on the floor, drop it and record the distance between where it falls and the center of the target. Imagine repeating this process many times. You was not get the same distance every time, but if you make a lot of measurement, the histogram of your measurement will approach a normal distribution. Any situation in which the exact value of a continuous variable is altered randomly from trial to trial. The random uncertainty or random error. Note if your measurement is biased, that is, the scale is off or there is a steady wind blowing the ping pong ball, then your measurement can be normally distributed around some value other than the true value or target. How do you use the normal distribution? You don't use the area under the normal distribution. For example, the area under the curve between x equal to a and x equal to b is the probability that your next measurement of x will fall between a and b. How do you get mu and sigma? To draw a normal distribution and integrate to find the area under it, you must know mu and sigma. Fx equal to 1 upon sigma square 2 pi minus exponential of x minus mu upon 2 sigma square. If you made an infinite number of measurements, their mean would be mu and their standard deviation would be sigma. In practice, you have a finite number of measurements with mean x and standard deviation s. For now, mu and sigma will be given later. We will use x and s to estimate mu and sigma. The standard normal distribution. It is tedious to integrate a new normal distribution for every signal measurements. So use a standard normal distribution with tabulated areas. Convert your measurement x to a standard score. So z equal to x minus mu upon standard deviation. Use the standard normal distribution mu equal to 0 and sigma equal to 1. Then area tabulated in front of text. Example, historical data shows that the temperature of a particular pipe in a continuous production line is 94 plus minus 5 degrees Celsius plus minus 1 sigma. You glance at the control display and see that T equal to 87 degrees Celsius. How abnormal is this measurement? Historical data shows that the temperature of particular pipe in a normally operating continuous production line is 94 plus minus 5 degrees Celsius into plus minus 1 sigma. You glance at the control display and see that T equal to 87 degrees Celsius. How abnormal is this measurement? Z equal to 87 minus 94 divided by 5, which is equal to minus 1.4. From the table in the front of text, minus 1.4 gives an area of 0.0808. In other words, when the line is operating normally, you would expect to see even lower temperatures about 8% of the time. This measurement alone should not worry you. The probability. What does the binomial distribution describe? The probability of getting all tails if you throw a coin 3 times. The probability of getting 4 twos if you roll 6 dice. The probability of getting all male puppies in a litter of 8. The probability of getting 2 defective batteries in a package of 6. So, these problems can be solved by using binomial distribution. Actually, binomial distribution is most important tools of the probability, under which it is very easier to understand and solve, and also logical. It is also known as Bernoulli theorem or Bernoulli distribution. And the PR, probability of R outcomes, is calculated by using the formula NCR PR Q N minus R, where PR is the probability of expected number, N number of observations, and R is the outcomes or expected number. P is the probability of success, and Q is the probability of failure, and C is a constant of combination. So constant of combination is used to solving the combination rules like NCR equal to factorial n divided by n minus r factorial into r factorial. Like Px equal to factorial n upon x factorial into n minus x factorial into pi into 1 minus pi n minus x. The probability of getting the result of interest x times out of n. If the overall probability of the result is pi, note that here x is a discrete variables, integer values only. In a normal distribution, x is a continuous variable. Binomial distribution is most probably used in a small samples. Usage of the binomial distribution: quality assurance, for genetics and for experimental designs. For these purpose, the binomial distribution is very useful to identify every kinds of future problems. To draw a binomial distribution, when n equal to 6% number of dice rolled, pi 1 by 6% probability of rolling a 2 on any dice, and x equal to 0, 1, 2, 3, 4, 5, 6 because a dice contain 6 edges. The percentage of 2's out of 6, y equal to binomial distribution x n pi. The variance of xy so it can be solved out by using the formula nc2, that means 6c2 1 by 6 की power 2 into 5 by 6 की power 4, that means n minus r. So 6c2 equal to 15 and 15 multiply 1 by 6 की power 2 multiply 4 by 6 की power 4. So 15 into 1 by 36 multiply 4 by 5 की power 4, and it can be solved to determine the answer or exact answer of the rolling 2. Another example, when n equal to 8, p equal to 1 by 2, percent probability of any pup being male. So q is also 1 by 2. It is because p plus q equal to always 1. So if p equal to 1 by 2, then q is also 1 minus 1 by 2, which is equal to 1 by 2. X equal to 0, 1, 2, 3, 4, 5, 6, 7 and 8. That means total number of observation is 8. Of males out of 8 is calculated by using for 0 males 8c0 1 by 2 की power 0 into 1 by 2 की power 8. That means 1 by 8, which is equal to 1 by 2, 56. 1 के लिए 8c1 1 by 2 की power 1 and 1 by 2 की power 7. 2 के लिए 8c2 1 by 2 की power 2 1 by 2 की power 6. 3 के लिए 8c3 1 by 2 की power 3 1 by 2 की power 5. 4 के लिए 8c4 1 by 2 की power 4 1 by 2 की power 4 once again. 5 के लिए 8c5 1 by 2 की power 5 and 1 by 2 की power 3. Then 6 के लिए 8c6 1 by 2 की power 6 1 by 2 की का स्क्वायर. 7 के लिए 8c7 1 by 2 की power 7 and 1 by 2 की power 0. And 8 के लिए 8c8 1 by 2 की power 8 1 by 2 की power 0. The shape of the binomial distribution. Shape is determined by values of n and pi. Only truly symmetric if pi equal to 0.5. Approaches normal distribution if n is large, unless pi is very small. Mean number of success is n pi and standard deviation of the distribution is npq or root npq, where n is a total number and p probability of success and q is the probability of failure. Example, while you are in the bathroom, your little brother claimed to have rolled a Yahtzee 5 matching dish out of 5 in one roll of the 5 dish. How justified would you be in beating him up for cheating? While you are in n equal to 5, pi equal to 1 by 6, x equal to 5. So px equal to factorial 5 upon x factorial into 0 factorial multiply 1 by 6 की power 5 multiply 5 by 6 की power 0. So p equal to 1.29 multiply 10 की power minus 4. In other words, the chances of this happening are 1 upon 7750. The Poisson distribution, probability of an event occurring x times in a particular time period. So px equal to e to the power minus m की power x upon factorial x, where m equal to mean of the distribution and the value of mean is calculated by using n multiply p, that means m equal to np. X is expected number or outcomes and e is an exponential constant. Here the formula is given in another form like px equal to lambda x e to the power minus lambda divided by factorial x, where lambda means average number of event expected during time period, that means it is equal to the m. Lambda determines shape of distribution. The binomial distribution approaches the Poisson distribution if n is large and pi small. Example, a production line produces 600 parts per hour with an average of 5 defective parts n hours. If you test every part that comes off the line in 15 minutes, what are your chances of finding no defective parts and incorrectly concluding that your process is perfect? A production line produces 600 parts per hour with an average of 5 defective parts in hours. If you test every part that comes off the line in 15 minutes, what are your chances of finding no defective parts and incorrectly concluding that your process is perfect? Here lambda equal to 5 parts per hour multiply 0.25 hours observed, which is equal to 1.25. X equal to 0, so P0 equal to e to the power minus 1.25 into 1.25 की power 0 divided by 0 factorial, so that 1.25 की power 0 divided by 0 factorial equal to 1, therefore e to the power minus 5, which is equal to 0.297 or about 29.7%. To draw a Poisson distribution, lambda equal to 1.25%, average defects in 15 minutes like 0, 1, 2, 3, 4, 5% number observed, and y is a Poisson distribution in x and lambda, and variance is xy, and it can be shown by a diagram like 0 chance for more than 25%, then 35% one chance, then about 23% of two chance, and 14% of three chance, and 5% of four chance, and 1 to 2% of five chance. Example, a production line produces 600 parts per hour with an average of 5 defective parts an hour. If you test every part that comes off the line in 15 minutes, what are your chances of finding no defective parts and incorrectly concluding that your process is perfect? Here, why not the binomial distribution? N equal to 600 by 4, which is equal to 150, which is large. So pi equal to 5 by 600, which is equal to 0.008 small. So you don't want to calculate 150. And now do it yourself. Question number 1, what parameters describe their shapes? Question number 2, how binomial and Poisson distribution useful in the statistics? And that's it from session number 6. Thank you.